this one, most likely. So variable assignments and initialization. That's an assignment. That's known as the assignment operator. I'm sure you know from prior programming classes that you cannot do that. However, C++ will probably not generate an error. That is not a syntax error in this language, unlike Python, unlike Java. What it does is it doesn't change the value of item. You would think that 12 would get copied over here, but really double equals does a comparison, right? And so it compares item to 12. Then it doesn't do anything with it, whether it was true or false. But that is legal syntax. You can type it into C++, and as long as you declared that variable, and it will not complain. But as always, you use a single equal to copy a value. You use double equals to compare them. That's called assignment. The difference between assignment and initialization is pretty simple. Initialization is just when you give it a value as you create it. If we did this, that's initialization. It's also declaring. I hope the textbook has been calling it declaring. Yeah, declare. So initialization is the act of declaring something and simultaneously giving it a value. Because if we'd wanted to, we could have done this. Int item is equal to 12. Same thing. Is one more efficient than the other? No, not at all. One just takes one line of code, one takes 2 lines of code. That's the only difference. So the variable has to be on the left. You cannot do this. It's not going to copy 12 over into item. They call that the LHS, left-hand side. Item is the LHS, or it has to be on the LHS, the left-hand side. The variable has to be, the thing that to change has to be on the left, and the value, because equal, assignment, always copies values from the right-hand side to the left-hand side. Variable initialization. Just as I mentioned, it's when you assign it as you are declaring it. See here they're switching terminology on us. They're calling it define here. They call it declare elsewhere. Same thing. You can initialize some or all values or none when you're declaring them. You don't have to initialize this. Like I said, you could declare it and then initialize it later, well, except assign it later. Here we are assigning one value to a variable, another value to a second variable, and then the third one we're not giving a value at all. That's okay. You can mix and match that syntax. These are all of type int, of course. If you wanted to declare a double at the same time, you can't. You have to declare all your ints on one line or one per line or whatever, right? That'd be fine. This would also be fine. I actually would kind of prefer to do this usually because then I could document what each one was with comments. Length of rectangle, right? And then width of rectangle. And so on. And then calculated area. Kind of explains why we didn't initialize that one. So, I'm not so terribly fond of listing all of my integers and then separating them by commas. Whatever. Do so if you want. So then there's something called auto. What auto does is it tells the compiler, okay, you pick what type to give it. So in this case, since we're trying to copy 100 into it, it would make it an int. Here, since literals that have decimal points are considered doubles, we're trying to assign a double into that value, so the compiler will make this a double. That's a character because it's got single quotes, it's got apostrophes around it, so it would turn into a character. And this is a long value, so it would make it a long. If we put an F here to force it to be a float rather than a double, then that would be declared as a float. Honestly, I see little reason to use that. But you can. Right? How hard is it to type int here and float there and char here and long there? It's not hard. But if you feel like letting the compiler pick it rather than you, feel free. That's what the auto keyword does. I'm probably not going to ever use it in my class demonstrations. Scope. Scope is the variable part. It's the part of the program in which the variable can be accessed. If you have a function like main, like this, and you declare a variable, and then later on you have another function, can you print out x? And the answer is no, you cannot. Because the scope of a variable is the braces in which it is defined. We can only get a hold of the contents of that variable between those braces. Doesn't matter in what order the functions are being called, we still can only have access to that variable in that function, unless we pass its value or something like that in as a parameter, as an argument. Yeah, you can shuffle values around as arguments. Now, in this language, you can declare global variables. If you wanted this variable to be accessible in main and in foo, then we can move its declaration outside. And now it's kind of like there's a pair of super braces around the whole thing. Imagine that. And so his scope is the entire file from which he is defined all the way down. Global variables, you should try to avoid them. They're kind of considered in poor taste. They make the code a little bit more difficult to read, and there are usually other ways to handle the problem, but they are available to you. And what you use global variables for is when a variable needs to be shared between more than one function. Now, when we talk about classes, there's an alternative to global variables that are much more functional and useful, and they're not frowned upon, unlike global variables are. So if we had this code, if we had an if statement here, if x is equal to 3, then int y is equal to 4. If we tried to print out y here, that's a syntax error. Why? Because the scope of the variable, his lifetime, is only between those two braces, so he's not available. If we wanted this variable to be accessed after the if statement, we would move its declaration up here. Int y is equal to 0, and then later on we could declare it to be 4. Now I'm going to show you something that would be a syntax error in Java, but it's not a syntax error in this language. That looks a little bit crazy, but it works if that's what your goal is. This variable only exists between these two braces. And when it disappears, it leaves this variable still hanging around. This variable will still have the value of 0. So when we print y out, it equals 0. You may think it's going to equal 4, but no. What equals 4 is the variable that was created inside of the pair of braces here. You can only declare one variable at the same level of scope with the same name. Right, this would be an error. Int x is equal to something else, right? Because now I have two variables named x. Or if I tried to give it a different type, like I want to make it a double, that would be an error too, because these are declared at the same level of scope. But I could stick this in here and do that, and that it would not count that as a syntax error. But the lifespan of this variable is inside the braces, and any changes to this one does not change the ones that were declared before. That's also known as variable hiding, right? X is now hidden. Nothing in here can change the value of this x. So a variable cannot be used before it is defined. Well, that's pretty obvious. We can't do this. X is equal to 7 or 8. Yeah, you could in Python, right? But x has not been defined yet. So you can't use it up here. Or you can't have an if statement that checks its condition before it exists, because things go top down within a function. Arithmetic operators. A binary operator is the one that you most commonly think about. Addition, subtraction, multiplication, division. It doesn't mean binary as in zeros and ones, although underneath it, everything in computers is zeros and ones, unless you're going to get way exotic and talk about quantum computers or something like that. Binary just means that it's got two operands. Addition is a binary operator, x plus y. X and y are the operands. There's also the unary operator. Unary, there's really only one that I know of, which is the negative sign. Right? What does a negative sign do? It makes the value after it negative. But only if it's a digit. Right? If you did minus x, it's not going to magically turn x negative. So I hardly ever think about the unary operator. I just assume that the minus means like that it's part of the number. But technically, when somebody was writing the compiler, that's how they did it. This was a special syntax character, a special operator that took the negative of the digits that followed. So mostly we're going to do binary operators, but there is one called ternary. Maybe we'll play with these. So I'm going to create a new project just because I get bored with y'all following along with me. So C++ app, empty, where'd it go? Right there. I need to look at the screen rather than up at the screen and yeah. I had it in the right place and I clicked on the, alright, that was dumb. Alright, lecture D. If you would all be so kind. Now I need my boilerplate. I'm just going to go and copy and paste it. So I'm going to right click on source files, add new item. I'm going to call it lecture D, although I could leave the name source.cpp, but that's a kind of meaningless name. I'm going to paste my boilerplate into it. Okay, so I'm just going to declare a couple of variables to play with. I'm going to give them some values. X is equal to 10, y is equal to 11. All right, so binary operator, z is equal to x plus y. Or I could even just see out the result of that. See out x plus y plus, and then arrow, e and dl. And I'm going to do x minus y. Then I'm going to do x times y. Guess what I'm going to do next? Division. Then what am I going to do? Well, how about floor division? Well, this language doesn't support floor division. It's going to consider that an error. When you're dividing two integers, when both operands of the division operator are integers, it does floor division automatically. But if one or the other or both is a floating point type, it does real division rather than floor division. And anyway, slash slash means comment, so we know that syntax wouldn't work. How about star star? That'd be great. This language does not support star star either. If you want to do the same thing, if you want to take something to the exponent, you use the POW math function. In some implementations of C++, you have to have an import to get the POW function to work. And this one you do not. I'm going to rewrite this statement. Cout POW x comma y, close parentheses, e and dl. That's how you take a number to the power of in this language. The same is true of Java, by the way, except you prefix POW with the name of a class. I think it's just math.pow. In other implementations of C++, you might have to import the CMath library in order to do that. And I'm curious if you Mac users need to do that or not. Is this a syntax error for you guys? All right, I think I had it paused when I added this statement to it. If you get an error about the POW function, go and do #include CMath. Microsoft is non-standard. They do not have the POW function require CMath in it. But if you're using this on Linux or on Mac, if you're using a GCC compiler or something else, you may have to have that there. So I'm going to add that to my boilerplate so it's there every time. Let's see if it works. Alrighty, seems to work. 10 to the power of 11 is 1 e to the 11. Well, I should have known that. It's a 1 followed by 11 zeros. Just like 10 to the power of 1 has 1 zero in it, and 10 to the power of 2 has 2. It's 100, and so on. Okay, so all of these are binary operators. Here's the operator, here's the operand. Here's the operator, here's the operand. Here's the operator, there's the operand. Now we're going to see something called the ternary operator. The ternary operator syntax is a little bit bizarre looking if you've never seen it before. Ternary meaning 3, like try, like triangle is 3. I guess a biangle would be 2. A shape with only 2 sides, I guess, would be a straight line. It's hard to imagine that. So anyways, z equals, and I'm going to put parentheses around it, but the parentheses are not necessary for the syntax, but it's clearer. X greater than 0, into parentheses, question mark, 1, semicolon, -1. Excuse me, 1 colon. That's a colon right there. I said semicolon. That was very bad of me. Make sure you get the first one as a colon, and then the last one, the trailing one, as a semicolon. So what does this do? It's like an if statement. I'm going to rewrite it as an if statement underneath it. Strictly not necessary, but if x is greater than 0, then z equals 1, semicolon, else z equals -1, like that. This one line of code does the same thing as these 4 lines of code. We could condense these 4 lines of code into 2 if we took out the carriage return there and we took out the carriage return there. But, so this thing performs 2 actions. If the thing before the question mark, the operand, which in this case is an entire expression, evaluates to true, then the second thing happens. Or the first thing happens, the first thing after the question mark. If this evaluates to false, the second thing happens. So if x greater than 0, 1, else -1. And then if you have an equal sign over here, then whatever happened, the result of it gets copied there. Now you can do some weird syntax with this, which I personally consider an abomination, but you can do it like this. X equals 10, question mark, cout, yep, 10, colon, y plus equals x, semicolon. All right, that's legal code. No, it's not. What do you know? Well, I'm going to take that out then. All right, that is valid syntax, but it's pretty hard to figure out what it's doing. What it's doing is it's like an if statement. If x is equal to 10, it does this. y equals y minus 2. Else it does this, y is equal to y plus x. Valid code. Would I ever write it like that? No, I would write it as an if-else because that's clearer. What if we store the result of this in a value, like that? This is even more perverse. If x is equal to 10, it would do this. Y is equal to y minus 2. Y was 11, so y turns into 9, and then that value would get copied into z. Else, y plus equals x. Well, y was 11, x is 10, so y plus equals x is 21, and then that would get copied into z. Now, as a matter of fact, x does equal 10, so when this printed out, it should print out 9 if I printed z out. I guess I could do that. If my calculations in my head are right, z equals, end space, end quote, arrow, arrow, z, arrow, arrow, endl. Now, it's entirely possible when I was calculating in my head I got it wrong, because that expression is pretty gnarly. Yep, z is equal to 9. I did get it right. This expression changed the value of y. You wouldn't think that in what is effectively an if statement, a single line if statement, should be changing the values here. So if I ever had something like this, I would break it apart and make it an if-else. But you can do it. So what I would do to make this clearer as to what it's doing, if I had to, is I would surround the evaluation expression in parentheses so that it's absolutely clear that that happens first. And maybe I'd put these in parentheses as well. Strictly not necessary, and experienced C++ or Java developers might think you were kind of goofy for doing that. But I think it makes it easier to read. So that's the ternary operator. The question mark is known as the ternary operator, and it requires 3 operands. It requires something before it, and it requires 2 things after it, separated by a colon. And if you leave any of those parts out, it'll fail. Just like if you leave a part out of any of these other binary operators, it'll fail, with the exception of minus, which can be treated as a unary operator if the thing immediately after it is a digit. So I'm going to play with that just a little bit. X is equal to 3. Y is equal to 4. Z is equal to all right, what is Z equal to after this line executes? Yep, it equals 12. Because this was evaluated, it was not true, so the thing after the colon was evaluated and then copied over, assigned into Z. How about this one? Well, that makes it kind of easy. I shouldn't have made it just exactly the same, but what's it going to equal now? 10. Right, because this is true. So this was evaluated and then assigned into Z. And this is basically the only way that I ever use the ternary expression. But like I said, you can make the code as complex as you want as long as what you are creating is an expression that can be evaluated. Now these could be function calls. You know, if we had a function called A, then we could do that. We don't have a function called A, so that would be a syntax error. And if we had a function called B, then we could do that. It's fine. You could do that. As long as we understand the basics, then you could expand upon its functionality if you wanted to. A weird side effect of this is that this would never get called if the answer is that. And this would never get called if the answer was that. And if you absolutely needed both of those called for some reason, you better call them beforehand and store their results. Undo all that. All right. I forgot the modulus binary operator. I bet either we've covered it in here in the past or you covered it in another class. Z is equal to x modulus y. Well, 4 goes into 3 0 times with a remainder of what? I'm going to replace these with numbers just because it's even clearer. How many times can 4 go into 3? None. And when you do that, what's the remainder? What's left over? All 3 of them. What about z is equal to 4 modulus 4? How many times, whoops, not 5. How many times does 4 go into 4? 1 time with a remainder of, come on y'all,
0.
Make it fun. Alrighty. And then, fun for me anyways. 5 modulus 4.
1.
Yep. How about 4 modulus 5?
1.
You would think. But 5 goes into 4 how many times? 0, so the remainder is 5. If you need help on the modulus, let me know. I can lecture longer about it. Also, you can read about it. It is another binary operator. So I'm going to go ahead and modify my code to include it up here. Do I need to lecture more on it? I shouldn't just say.
Well, the one question I think about both of us have right here is when 3 modulo 4 city came out to 3, 4 modulo 5 got to 5.
I think I said it wrong. Thank you for correcting me. What should it have been? Should have been 4. My mistake. I brought shame to my ancestors. Thank you. Alrighty. Are we good to go? We're almost at the end of the chapter. A closer look at the division operator. It performs different things. It does floor division. In other words, it rounds down if both operands are integers. But I'm not going to call it floor division anymore, even though that's what we called it in Python. I'm going to call it integer division. If both of these are integers, the result is an integer, and that can mess you up. If either operand is floating point, the result is floating point. Now, why did I say it can mess you up? Well, what's the formula for calculating the volume of sphere? It's 4/3 pi r cubed. We might think that we could do this. V is equal to 4 divided by 3 times pi. I'm going to cheat and just say it's 3.14159 times r cubed, which you could do r times r times r, or you could do PO, W r to the power of 3. I'm just going to make it r times r times r so that we don't have to include CMath. Okay. Looks good. It's not, though. Oh, come on.
That has to be fixable.
It's not. Man, that's irksome. Okay. Anyways, just need to remember that there's an inch of my screen I can't use. What's wrong with this? Well, what does this evaluate to? These are both integers, so what happens? Yeah, they round down, and so suddenly the equation just becomes 1 times pi. times r cubed. And our sphere does not have the right volume. So if you're doing division and you're worried about that, make one of them or both of them floating point. It was only strictly necessary for me to make one of them floating point, but I made both of them floating point. So if I ever have a formula that's like divided by 2 or over 10 or something, instead of making it divide by 2, I'll make it divide by 2.0 or 10.0 or whatever, just to avoid integer, unless I'm absolutely sure that one of the operands is floating. In that case, you don't strictly have to do it, but why not? Safety. That's important enough that I'm going to write it down. Division. If both operands are ints, the result is an int. And the same is true for longs. If one or both operands are floats, or doubles, the result is a float. So if both operands are ints, the result is an int, i.e. it is rounded down, i.e. floor division. I love nested parentheses. Only programmers do that. So 13 divided by 5 is 2.6. Or excuse me, 13 divided by 5.0 is 2.6. But if we change that to just 13 divided by 5, they're both ints. And that's what it displays. In this language, unlike some, modulus requires both of them to be ints. Python is such a weird beast that modulus will also work on floating point numbers. So if you take 300 and you modulus it by 2.5, it divides 2.5 into 300, and then we'll give you the remainder, which would actually be 0 in this case. But anyways, just know that modulus requires 2 ints. Comments. We've been using comments. Used to document parts of the program. Computer doesn't care about comments, but we do. It's intended for people reading the source code. What do? You describe the purpose of the program, you can describe the variables, you can explain complex sections of code. Strongly recommend you to use comments. I will probably make it mandatory at a certain point. So single line comments are the // multi-line comments are /*//, and I'm absolutely sure I've already demonstrated that in the past. And they can begin and end on the same line if you want. That's how C programmers did it up until the invention of C++. C++ came up with the the single line //, and then C adopted it in a later version. Named constants. Named constants, well, we've already talked about literals. Literals are just the numbers or the strings that are typed literally into your code and then require editing the source code in order to change. But you can store their result in a named constant. A named constant is usually what people think of when they say constant. I have 3 constants in my program. Usually they think the ones with the names. What do? You assign as constants the variables that are not going to change. Now, your textbook for fundamentals talked about constants, and then you weren't able to actually use them because Python does not support that keyword. But C does. If I went in here and I made a new variable, constant AA is equal to Z plus X, and then later on, well, I forgot to give it a type. Constant int AA is equal to Z plus X. That's great, but then if I turn around and try to change it, that's a syntax error. The compiler knows that AA was declared as constant and therefore must not be changed elsewhere in the source code. So typically what people do is like mathematical constants, like for physics and stuff like that, the speed of light, Avogadro's number, those could be defined as constants. The length of an array could be defined as a constant, so that you know that your array is 10 items long. Stuff like that. I guess if we'd wanted to, we could do this. How smart is that? Would it know that AA was a float if I made one of these a floating point number? I don't know. Let's find out. Sometimes I do things just because I am curious, not because I already know the answer and I'm asking you. 5.1. Okay. Auto is pretty smart. It added that one, which is an int. It took it and added it to a float. And then the result of it was a float. And so it made AA a float.
Can you make that a global?
Yes. Constants can be global. In fact, they quite often are. Like, double pi equals 3.14159. Double, a length, because we're going to have some kind of array, is equal to 10. And I'm forgetting to give a length should actually be an int. Like that, sure. Make them all constants. If the program's not supposed to be able to change them. The program's not supposed to be able to change pi. As a matter of fact, a lot of textbooks will say the only things that should be declared global are constants. Your fundamentals book said that, I believe. By the way, Python supports the idea of global variables, but it does so in an odd way. I don't know why I'm going to go and talk about this, but I know that 3/4 of y'all have had Python at least. You could do this, and then you could define a function, and you could use that. That works perfectly. X is treated as a global variable for the purposes of AA. However, it's not a true global variable because we could not change the value of it. If you did x is equal to 20, after it returned, x would still equal 10. Bizarre, but it's true, I believe. Has been when I've tested it. Instead, you have to say that x is a global variable. And then this function knows that when it changes, it's really supposed to change a different value. So really, anytime I'm using a global variable in Python, I go ahead and use that keyword, whether it's going to change it or not. Alrighty, let's delete that and talk about what we're supposed to be talking about. I don't want to call it that. Excuse me. Yeah, I guess I do. All right. This did not brush up upon something that I wanted to mention. Or maybe it did and I skipped past it. What happens if the variables are not of the same type for a binary operator? What if I do this? Int x is equal to 3, float y is equal to 4.0, and then cout x times y. Anytime the operands of a binary operator are not of the same type, one of them will be converted to the other. The less complex type will be converted to the more complex type. So we have int here, and we have floats here. The kind that is more precise is the float, because it can hold decimal points, partial values. So int would be converted into a float before it was multiplied. C, unlike Java, is real generous about doing assignments of the wrong type of data. If I turn around and do this, x is equal to 3.5, the C compiler won't complain about it. Or if I say x is equal to y divided by 3, 4, like that. Well, y is a float. This integer is converted to a float so that there'll be operands of the same type. 4 4 divided by 3 is like 1.333. Great, we're going to store that in x. The compiler will not complain, but in actuality, data is lost because x is an int, so we cannot store 1.333 in it. X is equal to 1 at this point. Java will complain and it will not compile. If you wanted this to work in Java, you would have to do that. You would have to cast the result to an int. In this language, you do not have to cast. I would prefer for you to cast anyways, just to show that you're aware of the fact that you're converting from one data type to another. You're aware of the risks of, of the expression being of the wrong type. You're willing to suffer the consequences of it being rounded down. There are 3 ways of casting. I'm going to show you 2 of them now, and we're going to see another way. If you do this, x is equal to int 3.4, 3.5. That will cast 3.5 into the form of x. How can it do that? Well, it rounds it down. X is 3. That's one way. This syntax should look real familiar to your Python guys. The only difference is that we can't put a string in there. Or you can do it like this. Same syntax I showed up above. That's the C style. And then there's a third kind. I will skip at this point. And then when we hit the PowerPoint that talks about it, you'll see it because the syntax is kind of odd. So this means take 3.5 and cast it. Why is it called casting? Well, like if you have iron, right, and then you melt it and you pour it into the mold. That's called casting it, and it's making it into the shape of the mold. So if this is the mold, we're taking our data, we've melted it down, and we have reshaped it into the form of an int. We are done with that chapter, I believe. Okay, we had one more, but it doesn't go into very much. Programming style, the visual organization of the source code. I had one student who flat out did not like blank lines. They refused to put blank lines. Man, their choice. I didn't count them off. I sure would prefer to see code with blank lines because it's like lines breaking up paragraphs of text, right? If you're reading a long paper or a book, maybe it's easier to read if there are lines between the paragraphs. So you can use blanks to break up the code. You can use comments to break up sections. I could do this. Demonstrate binary operators. And there's all sorts of fancy ways you can do that. I could leave these off. Sometimes I just do that. Then later on, okay, here we're doing something else. What are we doing? Demonstrate ternary operator. And then down here, what was I doing? I was still demonstrating ternary operators. What are we doing here? Demonstrating modulus. You're getting the idea. So I'm breaking my code up not only with blank lines, but with comments for large chunks of code. Just like if you were writing a paper, what was the standard format like in high school or in freshman comp? Introduction, and then 3 to 5 paragraphs supporting your introduction, 1, 2, 3, 4, 5, and then summary. Well, if we were computer programmers, our English teacher would be confused, but we might actually put a comment, introduction, right? And then, supporting arguments, and then summary, like that. And, and sometimes you will actually see things called out like that, right? The book has several sections in it. It's got the appendix, and it's got the different sections are all named, the chapters. So your goal is to write code that is as clear as possible. That also includes good tabbing practices. If you don't tab anything, then it's going to be harder to read. If you're copying and pasting and you don't correct your tabs when you do so, that can be a pain. Like what if I have some if statement here, and then I have another if statement here, and then I have another if statement here, and then I go, okay, well, I'm going to copy this stuff, and I'm going to paste it in here. All right, but Visual Studio corrected it. Visual Studio tried to correct it. If I'd been writing this in Notepad, it might look like that. And the more you copy and paste your code or cut and paste your code, the more your tabs get messed up. In this language, tabs do not have to be correct, unlike Python, but it's a good idea. Now, there may be a way of fixing it. Some editors will reformat your code. I'm going to see if this version of the C++ editor does that correctly. So I'm going to highlight everything. The easiest way to highlight everything is just with Control A. And I'm going to do Edit, Advanced, Format Document. See if that makes it better. Did that move my Z's in the correct? Yep, it did. Before I did that, they were not tabbed up correctly. After I did that, after I highlighted everything and hit Edit, Advanced, Format Document, or Format Selection, it does a pretty good job of tabbing it out correctly. If your code is if I ever think that your braces are off, and that's why you're getting syntax errors, which is possible, like if I leave off one of these, then it's going to wind up having a syntax error. It will not compile. There were build errors. So if I go down to the error list, I should be able to find out what the build error is. I need to zoom this in. There's my error list. Really? I said, here's my error list. End of file found before the left brace. Okay, so that means that it hit the end of the file without ever finding the terminating closed brace. That's easy enough to figure out. What if I had too many closing braces due to tabbing errors? Still not going to compile. There were build errors. Let's go look at my error list. And oh boy, look at how many errors we got. It just lights up all over the place. And if we start trying to fix them, this is when I know, and I'm going to tell you this, if I come over to a student and all the C outs are lit up in red, I know that it's because you had too many closed braces. But I only know that by experience, not because I'm super smart. Remember what I said about the purpose of the using namespace so that we don't have to prefix everything with std? One way to make it look like those errors are disappearing is to go ahead and add that. Oh, I'm going to add that. I'm going to add that. That makes those errors go away, but the problem is not fixed. Hopefully, eventually, we would figure out that we had too many closed braces. And once we fix that, all the rest of the errors go away. This is one of those cases where the first error is not the actual one that needs fixing. Usually I tell people to go to the first error and see what's wrong with it, but that wasn't the problem. It wasn't the first line of code. Usually I tell you fix the first one and then try to recompile it, because fixing one error can fix a whole bunch of them, just like we saw here. There were like 30 lines that were fixed by one, but unfortunately it wasn't the top one. Figuring out how to do this stuff is just experience. All right, we're done with chapter 2. Any questions over what I've covered? I would estimate that you already knew like 60 or 70%, and you certainly know how plus and minus and multiplication and stuff like that work. And I know that you probably knew the idea of scope. You may not have had the concept of global variables, but now you know them. Those are variables that are declared outside of any scope, usually above the first function in the code. All right, click OK and show me again what it looks like when you rebuild it. Do rebuild a solution. All right, so the reason it wasn't running is because it couldn't generate the exe because of these errors. So double click on that one and see if we can spot it. All right.
exceeded synaptic rate.
Excellent. Anybody else? Expressions and interactivity. This is going to cover some stuff that we have already covered. We will be able to slide through parts of this. If I ever go too fast, assuming that you understand something, slow me down. Like if I talk about order of operations and you don't really have that down, slow me down. The reason I might slide through something rather than show you each and every page is because if I do each and every page, we're not going to get through the good parts of the book. We're not going to get to classes. Classes are incredibly important, and yet unfortunately they're in a very late chapter. They should be earlier. I will be introducing the idea of classes before then just to make sure that we get to hit them. CIN. We've used CIN. That's a standard input object. It's what's known as a stream. It's an input stream. So you have to include the IO stream file. And information retrieved from CIN, you use the arrow. And this is very quirky. It's specific to C++. You won't see this syntax in Java, JavaScript, C#. We've already used it, so I'm going to kind of skip past that. Int height. See out how tall is the room. CIN arrow height. Now we are going to show a couple of things about CIN before we go too far. Maybe I'll put it up here at the top. Here under where we declare our three variables, I'm going to ask the user for these values. Cout arrow quote x equals question mark space end quote semicolon, and let's read in a value for x. Now just copy those two lines, paste them, and make them y and z. Reassure me we have used CIN already, right? We've been using that? Yeah, all along. Okay. And so when I run it, it asks me the question. X is equal to question mark. I can fill it in. So 10. X is equal to 10. Y is equal to 20. Z is equal to 30. And then the program continues to run. What I want you to notice is this. What if I type in more than one thing here? What if I type in 10 space 20? And I hit enter. Notice what it did. What did it do? It displayed y is equal to question mark, and then it displayed z is equal to question mark. What happened is that the CIN stream, quote, tokenizes the input, and anything that it doesn't handle is left in the buffer. 10 is a token. And then anything after the 10, spaces, tabs, the enter key, is all considered white space. And anything after that white space is left in the buffer, ready to be read by the next call. So we typed in 10, it got stored in X, but then 20 was left out in the buffer. And so the next time we used a CIN, it didn't even wait. 20 filled in Y. Now we only had two things in a buffer, so the third call actually had to sit there and wait for us to type it in.
Can you use periods? Like you could do decimal points with that.
Decimal points, and well, yeah, if we were storing floats or whatever, then that would work great.
Okay.
if we change these types to floats.
But, so just what starts the white space is just something other than a number? Or
White space is very specific. It's tabs, spaces, and
Oh,
carriage returns.
okay.
Yeah. If we want to make input that'll handle series of numbers separated by commas, it's a much more complex process than what we're showing right now. So if we run it again and I give it 3 values, 1, 2, and 3, it doesn't even wait, right? Because there was a 2 waiting in the buffer, so it copies the 2 into Y. There was a 3 waiting in the buffer, so it copies the 3 into Z. And why is that there? Well, because that was the first thing we printed after that. Why are these not spaced out with carriage returns? Because we didn't tell them to be. If we go back and we modify our code so that each cout statement is followed by an ENDL, it might be a little bit clearer as to what it's doing. So I'm going to do that. All right, X is equal, and then if I give it 3 pieces of input like I did before, you see what I did? Y is equal, Z is equal, and then it just ran on its merry way because we had already provided values for Y and Z. There may be times when you don't want that to happen, that you want the input buffer to be cleared before you call CIN. And there's a function you can use that will do that, that'll clear the input buffer. One case in which you would want to clear the input buffer is what if they type in bad data? These are ints. So we can't support typing in 1.5. Yeah, we can. But it messed it up. I wonder what Y and Z equal at this point. I guess I could print them out. But when we typed a decimal point in, it messed it all up. All of our future CIN calls were botched. So what we might want to do is to clear the input buffer before any additional call. Yeah, why don't we print out X, Y, and Z so that we can just see what the results were of our bad input. So cout arrow arrow X equals end quote arrow arrow X. And I'm just going to copy that statement and paste it and make it Y and Z. Then I'm going to run it again and type in a fractional value, a value with a decimal point. So 1.5, and whoops, it messed up. So X wound up being 1, Y wound up being 11, and Z wound up being that horrible number. Where did it get 11 from? I have no clue. How did it generate that negative 8 trillion, whatever it is? Well, I've seen similar numbers, but if we ran it in, if we compiled and ran it in release mode rather than debug mode, we would probably see something different. When we're compiling in debug mode, Microsoft is inserting all sorts of code that's supposed to help us in debugging it, like when we run the debugger that I've showed you a couple of times. But that fluffs up the size of the executable considerably. When you ship somebody an executable, you will change it to compile in release mode. Now we don't have to do that in here. There's no reason to. But I'm going to go ahead and rebuild my solution, and I'm going to run it in release mode, start without debugging, and when I type in 1.5 here, I'm not guaranteed to get the same results. Remember last time Y equaled 1 or 5, or I don't remember what it was. I think it was 1, and this equaled negative 800 billion or whatever. Different results. We're getting unpredictable results. We don't really like that. The way to handle that best would be to clear the input buffer between these calls so that there's nothing waiting. That 0.5 cannot exist and botch us up. Okay, I'm going to switch back to release mode now. What is a prompt? A prompt is the art and science of displaying a message and then waiting for input. How tall is the room? And then you let them enter the height. The CIN object. If you want, you can read in more than one thing. We could change our XYZ to do it all in one fell swoop. So I'm going to delete these 3 lines, or I could comment them out. I'm going to show you how to comment out easy. Yeah, I could just type / / / / / / in front of everything, but go to Edit, Advanced, Comments section, and it started it with a /* and it ended it with a //, which would not be my preferred way of commenting it out. I'd actually rather see all the //. And for you guys who edit code with NetBeans, and you can develop C and C++ code with NetBeans, so it's not outlandish for me to mention it. If you use NetBeans and you say to comment it out, it actually is going to prefix everything with //. Okay. Why did I do that? Because I'm going to change my prompt. Enter 3 numbers and then hit enter. \n. And then CIN, arrow X, arrow Y, arrow Z. This is not my preferred way of handling it, and I'll show you why. But perfectly valid syntax. Enter 3 numbers and hit enter. Okay, 100, 200, 300. And then it prints out X is 100, Y is 200, and Z is 300, and then we have another 300 because I forgot to put E and DL on my print statements. So that works. Why don't I think that's the bee's knees? Because when we run it and we typed in too few pieces of data, like I just type in 10, it just sits there. They may not figure out, and then they go, oh, was I supposed to do something? And they start hitting enter a whole bunch of times, and it still doesn't do anything, and then they type quit, and it blows up. So I would rather prompt them for the values individually, but you can do it that way. Enter the X and Y coordinates. What's better? Maybe telling them to separate them by commas and then doing the parsing to handle the commas or something like that. But that's considerably more sophisticated than what we're learning right now. So the order is important. If we CIN height followed by width, the first number that they type gets stored in the height, and the second number they type goes into width. And if they typed in 3 values, that third value would be left in the buffer for the next CIN call. Mathematical expressions. It's just a series of pieces of data and operators acting upon it. Now, an expression can just be a single piece of data. That is a valid expression. Normally when you think of, well, at least I do, when you think of an expression, you think of it as being something like multiplication and division or whatever. You think of more than one piece of data and, with 1 or more operators in it. An expression can be a literal, a variable, or a combination of literals and variables. And you can use it anywhere that a value is expected. Like this 2 could be an expression, a kind of a sub-expression, right? X plus Y. Now I've botched it actually. Somebody tell me why that would be stupid, what I just did.
Multiplication comes first.
Yeah, multiplication comes first, so that would be bad. So what I should do is do that. Something to know about expressions, and I'm sure that this is a test question, that if I give you a formula like this, area of a cylinder. If I give you a formula like that, you have to put the asterisks. If I say that the equation is it already time to go?
Yeah.
Whoa, I've had way too much fun talking. Let's close this. Did I have any homework queued up for y'all? Nope. go get some homework.
Well, it's due on Monday.
Yeah. I want to try to get us something to do.
Are you gonna open up a Dropbox for today?
Yeah, let me do that as well. I think you probably know enough to do this one. But I'll make the due date a considerable amount of time so that if we have to lecture additionally on it Tuesday, we can do that. But those of y'all who want to try it. So cost versus profit. Ask the user for the height and width of a shape. Calculate the cost and the profit for the shape according to the following formulas and display the cost and the profit. So here are the formulas. The volume is equal to length times width times height. The cost is that times this constant. The charge is equal to volume times this constant, and then the profit equals the charge minus cost. And I give you some source code to start with to make it pretty dang easy. So that'll be our homework. Let's make a Dropbox. All right, refresh your Dropbox or click Assignments. You'll see folder D. And enjoy your Monday off, unless you have to work, in which case you don't get it off. And I'll see y'all Tuesday.
Do we necessarily have to put our files on that, or do you?
I want you to upload something,
Okay.
even if you didn't type in any C code, just upload a text pad file saying Dallas here.
Oh, okay.
Well, it's wanting us to type something in, so put your cursor here, click on that, and then type in a number. And type in another number, it's asking for something else. Yeah. So each one of those CIN statements is waiting for input. And if we don't type in something and hit enter, then it's not going to continue to run past it. Right. You have the coolest people ever. Love that. See ya. You okay on yours? Yeah. Sure. All right.
Have a good night, sir.
Oh, you too.
You were explaining a test question, are you gonna explain that later?
Yeah. What it was, and since you asked about it, is that the equation is something like 4x plus 3y, and I asked you to write that. You just better put 4 times x plus 3 times y, just like it was a calculator, right? You have to put the symbols to do the multiplication. And I'm absolutely sure that when I give this, at least one student will leave the multiplications off. Maybe not in a class this size. 20 people, 1 or 2 would.